The MagiCAD piping tool is an easy and accurate way of modelling pipework within your model. Using the piping tool, you can select a system before you start to model. You can select a piping family, like so, with your routing preferences, whether you want a tap or a T. You can also select the size of your pipework, add any insulation series, and a sizing method here for later on with using the calculations. You also get live offsets for your pipework for the top of the pipe, centre of the pipe, bottom of the pipe, and this is all dependent on the size. And if you notice, if I take this insulation off, it will then automatically update. Not only that, we can reference any object within our model. So for example, top of top, I can select here, select this pipe within my model, and then you'll see that it's updated to the top of my pipe there. And now I can start to model. And what you'll see is it's matched to the top of that pipe. Not only that, if I go back into the piping tool now and select this justify to selected object, I can go on top of that pipe. So for example, I select there and then select this pipe here, but I don't want that pipe directly on top because it's updated the bottom of my pipe there. I can put a 100mm tolerance in there, press OK, and then what I can do is draw that pipework over there. And you'll notice within my section it's 100mm. The vertical crossing tool helps you with coordination within your model. As you can see, we've got a single crossing and a multiple crossing. The only one I'm going to show you now is the multiple crossing. So you'll get three options of how you want to cross. I'm going to use a smart move, or you can use a 2 points. But what I need to do is select the objects that I want to amend. So as you can see, these ducts and pipes are clashing with this rectangular duct. So I can select them, and then I get to select if I want to go above, below. So I'll select this rectangular duct because now I'm referencing the offset. And then I will get this dialog box. And as you can see, I'll get a preview by using this box. I can also close it. But you'll see on the 3D model and the section as well, it will give me what it's about to do. And then in here, I've got my tolerances. So these is my maximum tolerance. And then I've got my minimum tolerance. So basically what these are, the bottom one is how high these fittings can go to without running into each other. And then you've got the high tolerance, which is how high it can go before these fittings start to cross each other. Okay, so anything between this 4205 and this 2613, I can put in my offsets. I can reset all my offsets if I want. I can change my angles, and you'll see that the models will update when I do this. And I can even go back if needs be, and the tolerances will change. What you'll notice is, in here, you'll notice that that is right on top of that duct, which is not what we want. So what we can do, we have this box here where we can add a tolerance, and then we can then update. And as you can see now, I've got a tolerance of 100mm in between that duct. As well as the vertical crossings, we've also got horizontal crossing, singular and multi. I'm going to show you the multi now. Again, we can use the same crossing methods. So I'm going to select two methods here. And what's nice is I've got two ducts on top of each other here. It will give me an indication of which one I'm selecting with the offsets and diameter and even systems. So what I can do is I've clicked a point there, and then past this steel here I can select again. I will then get the plus, which then I can add in the multiple pipes and ducts. and then I can go up here and press finish. And then what I need to do is select the end of that steel. And now what will happen is it will run through the crossing method. As you can see, it's done the pipework and the ductwork at the same time. I've got my tolerances again. I can swap sides if needs be using these arrows that I can see on the preview as well. But I might have to readjust, so I can readjust the base point there. I'm going to go back to what I had before. I've also got a tolerance as well that I can add in there, and again I can change the angle. And once I press OK, as you can see, that has then created that avoidance or the clash. The angle to horizontal tool is an easy way of creating branches off pipework or a change of level within pipework using an accurate angle. So using the tool, I'm going to create a branch, so wherever I select here, it will create a branch. And I'm going to create that branch and run underneath this pipe. So as you can see, you get the opportunity to select your angle. I'm going to select 45 in this case. You also get the opportunity to change your pipe size. You get the opportunity to add insulation or a sizing method. That will be used later on in calculations. And then here are the offsets that I want to go to. So I can either type it in here and put my offset to the center of the pipe, or I can reference an object within my model, which I'm going to do. So I'm going to reference this object, and what it'll do is it'll reference the bottom of that object and put it at the top of my pipe. But what I want to do is put a tolerance in there, so I'll put 150mm tolerance. It will then ask me which side I want to branch off at, so the right or the left. I'm going to go off at the right in this case. And as you can see from the 3D view and from the section, it's created a 45-degree angle off my pipework to the offset that I've set, and then I can continue drawing. What it's also used for is I can also click this angle to horizontal on the floating toolbar, and if I want to drop to a level at 90 degrees here, I can then just type in 250, and then that will drop my pipework down to 250mm offset straight down. So I can do this all within a plan view. And as you can see over here, it's rotated that T into 45 degrees and dropped it to the offset that I was required, which is very difficult to do in native Revit. And as you can see from the section, it's done exactly the same. The Smart tool is a tool that will help you readjust any offsets that might need readjusting after any ducts have changed. So for example, here in this section, I have got a offset of 100 between these ducts. But what if this duct has changed in height and now it's gone up to 350? I've lost my offset now. So I can use the Smart move. I could either do it in plan view or section view, and I can click on that section. Click on there and I can readjust to any offset, but I want to still go on top of. And as you can see, the tolerance of 100 is already in there. So all I need to do is press OK. And now it's shifted that up, and I can quickly do the rest. And it will remember my tolerance again. And then I can shift these all up so I can maintain my 100mm offset that I set out when I first done the coordination. And then that is the Smart tool. Standard connection tool is an easier way of connecting ducts to branches, mains, etc. You can use it singularly. So if I want to connect this branch into this main and select like that, wherever I've selected, it will create a connection between the two. I got the opportunity to change from T to tap or vice versa. I'll choose a tap in this case, and then I'll get my first and second angles. So as you can see from the plan view, 3D view, and the preview that you have here, I can select different angles to come off at, and it will rotate the fitting around the duct, like so. I press OK, it will then create that connection. But not only that, I can select the end of this duct here, and I can even select the elbow on this one. And as you can see, it will give me the options again, and I can flick through and see which ones I actually want to have on there. So maybe it's this one, and I'll press OK, and as you can see, it's converted that elbow into a T. A new update to this tool is the multiple connection. So what I can do is select all these systems, and then what it'll ask me for is to create a connection. And as you can see from the preview, it's a similar sort of menu, but what it will do is connect each one of these systems up multiple. And again, I can choose which ones I want. So I want to match the existing ones, press OK, and then the system is connected. Using the Install Product tool, I can easily select and place any radiators within a model quite easily. As you can see here, I've selected this generic radiator, and then I can select the system with the temperatures in here, like so. I can also then select a radiator using this target power here, which will be your heat loss. So I can say select size. I could then change any of this criteria in here to suit what I wanted. I could then calculate here, and it will bring me up everything within my data set that to this criteria here. But if I just wanted to use that radiator product, I would say uncheck this box. So there you can see there's only one there, but it's a bit high. So I'll go back to all products, and then I can choose my best fit, which will probably be this one here. Press OK. I can also select my connection sizes. Once I press OK, I'll get this floating toolbar here that will give me my offsets to the bottom and the top. I can also select my connection locations, and again I can give this a code for the system, so LTHW flow, and then again I can put that LTHW flow in there as a description. Press OK, and we've already got a return here, so that one's in there. And once we've done that, I can go on the array and use this draw line command. And then from here I can put I want number, and there's 4 rooms here, so I'm going to press 4 and then grab the corner of this room and then the corner of this room, and what it'll do is it'll place them radiators in there like that. But what we also want to do is we want to select some valves for that radiator, so we can use the valve tool, and then we can select this TRV2 and the LSV, and make sure we select the correct sizes, press OK, and then from this I can update at any time and offset from this line and put 50mm, and as you can see it'll move 50mm away from the line. Once I click apply and apply, it will then install the valves, install the radiators, and it's a quick way of installing radiators within your model. Now I can press escape, and as you can see it's installed them 4 radiators within them rooms quite quickly. Using the pipe connection, you can easily connect up a bank of rads like so. If I just select these 4 rads here, it will then ask you for your flow and return system. Now wherever you select, it will create a branch, and then you will get the following options here. As you see down here on my 3D view, it's already put in a solution, but then I can adapt these options if I wanted to. So if I needed to drop straight down and run at low level, then I could select this one, and as you can see it's dropped from low level straight from the main, but I want to run at high level in this case. I also get the opportunity to select some dimensions here and some offsets. And what I can also do is, if I know what offset I want my pipework to run to and then drop to all level, I can then set them here or use any references here. What I want to do is I want the center of my pipe there to go about 2600, and all I can do is press refresh, and you can see this is not into my model yet, but I can still adapt to suit what I want to see within my design. I can also change the piping series and also add any insulation or any sizing methods straight from here with this device connection. And once I press OK, you'll notice that it'll install all that pipework running at high level, dropping to below, and then running down to the radiators here, as you can see, and connecting them up. When using MagiCAD, we offer a wide range of calculation standards that you can set within your project settings. As you can see here, we've got the piping settings where we've got EN 806. We've also got UK BS 8558. And then we've also got the plumbing and heating guide, the CIBSE. And when selecting one of these will load in the diversities within each product and will allow you to calculate towards whatever standard you want. And as you can see, we've also got some European standards in there as well. Using a heating and cooling sizing calculation, we can easily size heating and cooling pipework. As we'll show here, you can select your sizing methods that will be set within your MagiCAD dataset, and you can also set some other criteria as well. Once you've selected that criteria, you select anywhere on the system, and you'll be provided with this heating report where you can select between the systems of supply and return, and this is a bi-directional report, so I can highlight anywhere within the report, say highlight in drawing, and it'll zoom to it within the model, and also vice versa. If I click on the model, it will come up on the report, and I can interrogate the details from there. I can also copy this to an Excel spreadsheet or copy this to PDF, and then we've also got the general results as shown there. And then once you press OK, all that data will be pushed into the pipework. So now that data exists within that system. I can also do the balancing on this system, so basically get an index run. So I'll get my balancing options here. Again, I get some balancing method that I can set, but this one will be my index run, where I can balance the minimum pressure and also balance the minimum pump pressure, where if there's a pump on the system, it will use that pressure. And then I've also got balance of feed point pressure, where I can add just a pressure onto that system. Once I press OK again and select on the system, I can interrogate this report where it's got all my details. It's got my pressure that needed, it's got temperatures, it's even got the return pipework on there, and I've also got the general results again, which labels all the project information that's necessary. I've also got system volume as well. I've even got the thermal conductivity of the pipes and all the calculation ranges within here. And again, I can copy this to a PDF. In the PDF, you'll get all the relevant project information. You'll get the calculation information for the data, and also any inputs that you might have. And then you can see here about you've got the pressure drops and the velocities and temperatures and flows, and a simple schematic running down along with the index run highlighted in green. And once you're happy with the report and sizing, you can press an OK, and then that will push all that data into the model, like so. What we're going to be looking at now is the domestic water sizing. As you can see, we've got a small system with a water heater with the mains coming in. We've got a few devices on here. This is a dummy device that we're using MagiCAD to hide under the sink with two connections, hot and cold. We've also got some connection nodes on, which are used for future designs or early stage designs, where we need to put a load in there and a pressure to be incorporated within the calculation and size that pipework correctly, but we might not necessarily have the full details of that system going downstream. But we can also tag that with these tags, and it will give you the system and the loading units used within that node. They can also use for fit outs, where you can cap off in the ceiling. So as well as the domestic dummy devices, we do also have taps, as you can see there. But now we can move on to the sizing. So this is the sizing option report, where we can choose a sizing method for each system and a few other things in there like ambient temperature and any warnings that we might want to see within the report. We click on the system we want to size, and as you can see here, we've got the report where we can flick between systems, hot and cold. We've also got the circulation water in there as well. Within this report, we've got a simple schematic down the left hand side, levels, type of the actual branches and lengths. We've also got the product that's being used, size, old side if it's been changed, length, insulation, flow, loading units on there that have been diversified from the loading units, and you've got the diversified flow there. You've also got the pressure drop per meter and the sizing method used within there. And you'll also notice we've got a few warnings there. These warnings are flagging up because the software is actually using the CIBSE guides, and it's telling us there that there's low pressure within each of them branches where it's been connected. We've used 15 mil in this case for these warnings that have come up. The software is actually saying that we are using should be using 22 mil according to the guides, but from experience we normally always use 15 mil to one basin. It's also bi-directional, this report, so as you can see, you can jump to the device by clicking on the report, and you can also click on the model and it will jump to the report where that is in the report. So it's very intuitive, and you can interrogate your system and your design all from this report, and anything you're not happy with you can change. As we can see here, that we're going to change these pipe sizes to 22 to get rid of that warning. You might not necessarily do that, but it's just what the warning is telling us. Again, you could live with that warning if you wanted to, but I'm just using this just to show you how you can change the pipe size within the system to alleviate some of the warnings that we might have. And if you right click, you can see in more detail what the warning is actually telling us. Okay, so I've changed the pipe size there and it's locked it, and if I go to this update sizing, you'll notice that the warning has now gone because we've increased the pipe size on there, and then you can see that the warning has gone. You can also create a PDF from this by going into the top left at edit, and you will be given a nice PDF report that I will show you in the balancing. And once you're happy with the system, you can interrogate it all like that, and like I said, with the hot water, you'll see that the loading units are added up back to the system. And here it's just showing that the water heater is being accounted for, and it's being pushed into the mains from the hot water and the cold water demand within the system. You'll see here that that's the water heater there. And then once you press OK, all that information will be then pushed into your model, and then it will resize all your pipework to suit. So once we've sized the system, we can now go on to get a pressure for the system by using domestic water balancing. And we'll get similar options as the sizing, but in this case we can use a specific pressure there, or we can calculate the required pressure using a specified pressure outlet, which we've used 100 kPa here, 1 bar at the outlet, and there's a few other criteria we can add there. Once we select the system we want to balance, we will get the same report as the sizing with a few differences, obviously to reflect the pressure. What we've got here is a simple schematic with the index run highlighted in green. It will also show this on the model. And then we can also show this route only, so we can interrogate that if we want to check where the pressures have come from. And we can also check the K values on fittings and the pressure data on fittings. As we can see here, there's the flow, the pressure drop, the data source, so it's from the CIBSE Guide C. Even the data table within CIBSE Guide C is on there, the number table, and then it will give the corresponding K factor that is used within that fitting. We can also look at the device that's being used. This is the dummy device, which is the index run. And then we can also look at the product of the tap. We can also flick between each system. As you can see here, to interrogate it, we've also got a general results that will give you project information or any calculation data that you've put in there or calculated. And you've also got the fluid densities in there and the viscosities and even the network volume within that system. And you press OK and update to model, and again that will push all that pressure data details into the model.